To this video of simple repair work and assembly of machine parts from blueprints. Maintenance of machine involves regular servicing of equipment, routine checks, repair work, and replacement of worn or non-functional parts. In this video, we will understand the basic maintenance concepts like total productive maintenance, autonomous maintenance, and identification of defects in a lathe tailstock.
Total Productive Maintenance or TPM aims to maximize overall equipment effectiveness, establishes a complete system of productive maintenance for the machine's or equipment's entire lifespan, is implemented by various departments: engineering, operations, maintenance, quality, and administration. TPM can be considered as the medical science of machines. TPM involves every single employee from top management to all the operators on the shop floor. TPM raises and implements productive maintenance based on autonomous small group activities. TPM is a maintenance program which involves a newly defined concept for maintaining plant and equipment. The goal of TPM is to an extent increase production while at the same time increasing employee morale and job satisfaction. TPM brings maintenance into focus as a necessary and vitally important part of the business. It is no longer regarded as a non-profit activity. Regular maintenance will minimize downtime of the machines and maximize production. The goal of TPM is to stop the emergency and unscheduled maintenance. Form different teams to reduce defects and self-maintenance. Advantages of TPM: avoids wastage in quickly changing economic environment, produces goods without reducing product quality, reduces maintenance cost, produces a low batch quantity at the earliest possible time, ensures the non-defective goods to the customers, reduce customers' complaints, reduce accidents, follow pollution control measures, favorable change in the attitude of the operator. Autonomous maintenance is a maintenance approach for routine maintenance tasks to keep the equipment in good condition and prevent breakdowns. Let us see the step-by-step improvement process and understand the equipment functions and safety risks. The 7 steps of autonomous maintenance: initial cleaning, initial inspection and registration, detect problem of the lives and restore the original state, start managing the line autonomously, create and perform temporary cleaning or lubrication, source of contamination and hard to reach areas, solve by cleaning, inspection and lubrication. Standard of cleaning and lubrication: develop tentative standards for cleaning, lubrication and inspection. General inspection: provide training on their equipment, products, materials and inspection skills. Autonomous inspection: develop a routine maintenance standard by operations. Standardize autonomous maintenance operation: standardize routine operation related to workplace management such as quality inspection of products, life cycle of jigs, tools, setup operation and safety. Autonomous management: autonomous team working. Tailstock: it is a sliding unit on the bedways of the lathe. It is mounted on the right-hand side of the lathe. It is made in two parts, namely the base and the body. The base bottom is machined accurately and has V-grooves corresponding to the bedways. It can slide over the bed and can be clamped at any position on the bed by means of the clamping unit. The body of the tailstock is assembled to the base. Graduations are marked on the rear end of the base and a zero line is marked on the body. When both zero lines coincide, the axis of the tailstock is in line with the axis of headstock. The body and base are made from cast iron. The parts of a tailstock can be seen on screen. Purpose of the tailstock and functioning. To accommodate the dead center to support lengthy work to carry out lathe operations. To hold cutting tools like drill bits, reamers, drill chucks provided with taper shank. To turn external taper by offsetting the body of the tailstock with respect to the base. Functioning of a tailstock. By rotating the hand wheel, the barrel can be moved forward or backward. The barrel can be locked in any required position. The hollow end of the barrel at the front is provided with a Morse taper to accommodate the cutting tools with a taper shank. Graduations are sometimes marked on the barrel to indicate the movement of the barrel. With the help of the adjusting screws, the body can be moved over the base laterally and the amount of movement may be read approximately referring to the graduations marked. This arrangement is to offset the center of the tailstock as required for taper turning. Identifying defect in tailstock. Identify defect in a tailstock. Rotate the tailstock hand wheel for moving the spindle. Lock the spindle using the locking lever. Rotate the tailstock hand wheel and check the spindle movements and locking position. If the spindle is not locked properly, it will move. Hence, it is known as screw rod spindle lock is not working properly. Dismantle the spindle locking unit from the tailstock. Prepare the new screw rod instead of defective screw rod. Assemble the prepared screw rod instead of worn out screw rod. Check the tailstock performance and lock the spindle in the proper position.
In this video, we have learnt importance of maintenance for the overall effectiveness of equipment, inspection and identification of defects in tailstock. Thank you for watching. Hello everyone, welcome to this video of Rectify Possible Assembly Faults During Assembly. In this video, we will understand how to inspect the drill head of a pedestal drilling machine, hydraulics of power saw, grinding wheel of a grinding machine,
and examine jib strip on lathe carriage. Dismantle assembly of spindle and pulley of drilling machine. Remove the drill chuck and arbor from the spindle, part number 20 and 19 in the figure. Switch off the machine and remove the belt guard. Remove the V-belt, part number 1 from the pulley. Removal of spindle pulley and hub assembly. Loosen the nuts, part number 2, from the spindle hub, part number 4. Remove the stepped V-pulley, part number 3 from the spindle hub. Remove the feather key, part number 5. Remove the internal circlip, part number 6 from spacer, part number 8. Remove the external circlip, part number 9 from the end of spindle hub, part number 4. Remove the spindle hub and bearings, part number 7 from spacer. Removal of spindle sleeve. Remove the pinion with shaft from the machine. Straighten the toothed washer, part number 11. Loosen and remove the nut, part number 10, from spindle, part number 17. Remove the toothed washer from the spindle. Remove the bearings, part number 12, from the spindle sleeve, part number 14. Remove the O-ring, part number 13. Remove the spindle sleeve, part number 14. Remove the spindle, part number 17, from the spindle sleeve. Remove the thrust bearing, part number 15, from spindle using hydraulic press. Clean all the dismantled parts and dry it. Identification of worn out and damaged parts. Check all dismantled parts of spindle and pulley thoroughly and list out the damaged, worn out parts and fill up the table given. Replace the worn out and damaged parts and assemble the spindle and pulley. Assemble all the parts of the spindle and pulley in the reverse order and apply grease and oil at necessary parts. Fix the V-belt and adjust to proper tension. Mount the belt guard. Test run the spindle. Switch on the power supply. Check the runout of the spindle by using lever type dial test indicator with magnetic stand. Run the spindle at low, medium and high speed at least for 5 minutes. Listen if any abnormal noise hearing from spindle assembly. Check any noise generating in the spindle assembly. If so, rectify the fault and run the spindle without noise. Rectification of hydraulic fault in power saw. Switch off the machine and remove the belt guards. Support the arm properly. Drain the hydraulic oil and keep it safely. Remove the connecting pin, circlip, split pin and loosen the fasteners in the hydraulic unit. Disconnect the oil lines and remove the hydraulic unit from the machine. Dismantle the hydraulic unit and keep it in a separate tray, figure 2. Clean all the parts and dry it. Inspect oil flow part with compressed air. Inspect the oil seal, O-rings, filter, control valves and valve seat. Replace or repair the worn out or damaged parts. Assemble the hydraulic unit in the reverse manner of dismantling. Fix unit to the machine. Check the condition of drained oil. If contaminated, fill as per manufacturer's recommended grade oil. Connect the oil lines and drive system and remove the arm support. Trial run the machine and observe the performance. Check any leakage in the oil line. If found, arrest them. Adjust the control valve and verify for arm lifting and descending performance. Fix the belt guards. Assembling of a worn-out grinding wheel. Switch off the electrical power supply. Dismount the safety glass bracket. Remove the grinding wheel covers. Unscrew the nuts from the spindle of the grinding wheel. Remove the tool rest. Remove the grinding wheels from the spindle. Disengage the grinding wheel head unit from the main body. Dismantle the wheel spindle from the wheel head. Extract the ball bearings from the housings or spindle. Clean the ball bearings and other parts. Inspect the bearings and other parts. Replace the bearings if necessary. Lubricate the bearings and other parts. Assemble the parts in the reverse sequential order. Replace the grinding wheels if necessary. Check the bench grinder for smooth running. To dismantle and assemble jib from the cross slide of a lathe. Remove the adjusting screws from the dovetail slide. Dismantle the jib from the cross slide. Clean the slide surfaces. Check and inspect all the parts. Damaged parts of jib strip and adjustment screws should be replaced. Lubricate the slide ways. Assemble the jib and check the jib seating. If found any defects, rectify it. Check adjusting screws thread. Lubricate the slideways of jib strip. Assemble slideway jib strip with saddle. Tighten the adjusting screws to give the correct freedom required in the assembly. Lock the movement of the adjusting screw by the check nut. Check the slideways smooth movement without any shake. To adjust and align the jib strip in a lathe. Loosen the lock nuts. Remove the set screws. Pull the jib out. Clean all the parts. Check the straightness of the jib using Prussian glue. Scrape the jib to get even surface to prevent stick-slip motion of the cross slide. Lubricate all the parts. Assemble the jib into the dovetail slide and position it. Adjust the screws and eliminate the clearance between the slides for getting the correct freedom required in the assembly. Lock the movement of the adjusting screws by the check nut. Hold the jib in correct position firmly while locking with check nuts. Check the function of the cross slide.
In this video, we have learned to dismantle the spindle and spindle pulley from drilling head, clean and inspect the parts for wear and damage, assemble the spindle and spindle pulley and check for proper function, rectify the hydraulic faults in power saw, dismantle and assemble the worn-out grinding wheel,
Dismantle and assemble the jib from the cross slide of lathe.
Thank you for watching. Hello everyone, welcome to this video of
Perform the routine maintenance with checklist.
In this video, we will learn the importance of routine maintenance, preventive maintenance, and describe the normal procedure followed in machine tool maintenance in the shop floor.
In order to get trouble-free service from productive equipment, it is necessary to carry out these following activities: lubrication, periodic inspection, adjustments of various parts, cleaning. All the above maintenance operations are carried out while the machine is running or during pre-planned shutdown. This type of maintenance may prevent breakdown of equipment. Routine maintenance should not interfere with production schedules. Planned preventive maintenance (PPM), more commonly referred to as simply planned maintenance (PM), is a scheduled maintenance of an object or item or equipment. Specifically, planned maintenance is a scheduled service visit carried out by a competent and suitable agent to ensure that an item of equipment is operating correctly and to therefore avoid any unplanned breakdown and downtime. Along with condition-based maintenance, planned maintenance comprises preventive maintenance, in which the maintenance event is pre-planned and all future maintenance is pre-programmed. Planned maintenance is created for every item separately according to manufacturer's recommendation or legislation. Plans can be date-based, based on equipment running hours or on the distance traveled by the vehicle. A good example of planned maintenance program is car maintenance, where time and distance determine fluid change requirements. A good example of condition-based maintenance is the oil pressure warning light that provides notification that you should stop the vehicle because engine lubrication has stopped and failure will occur. Advantages. Planned maintenance has some advantages over condition-based maintenance (CBM), such as easier planning of maintenance and ordering spares. Costs are distributed more evenly. No initial costs for instruments used for supervision of equipment. Preventive maintenance consists of a few engineering activities which help to maintain the machine tools in good working order. The basic activities of preventive maintenance are the periodic inspection of machines and equipment to uncover conditions leading to production breakdowns or harmful depreciation. Upkeep of machines and equipment to avoid such conditions or to adjust, repair or replace them while they are still in the initial stages. Advantages of preventive maintenance system. Less downtime in production. Improves quantity and quality of product. Standby equipment is not needed, which saves capital investment. Lower unit cost of manufacture. Reduces major and repetitive repairs of machines. PM helps in prolonging the life of the machines and reduction in unexpected breakdowns. Functions of Preventive Maintenance Department. Periodic inspection of machine and equipment as per the checklists. Lubrication of machine and equipment as per the manufacturer's instruction manuals. Servicing and overhauling of machine and equipment as per the PM schedule. Keeping basic records of each machine and equipment. Analysis of inspection reports and systematic review of reports of machine and equipment. Normal procedure followed in machine tool maintenance on shop floor must have some procedure and sequence. If maintenance is followed without any procedure, there will be time loss and the machine and equipment could not be ready in time. The procedure guides the maintenance people how to start, execute, where to inspect, and how to complete the maintenance on time. The maintenance is carried out with the following procedure. Initial cleanup. Main machine, connected accessories, lubrication system, panels, and adjacent parts are to be cleaned first. Identification of fault. The fault of the machine is to be identified by visual inspection. Dismantling. The fault area is dismantled with reference to the manual and all the spares are kept separate in a tray and preserved safely. Inspection. All the dismantled parts such as gear, bearing, shaft, key, etc. are cleaned and inspected for damages. Such damages or breakage is recorded in the maintenance checklist. Identification of cause for defect. The defect in spare parts is thoroughly examined and analyzed. The cause for damage has to be rectified. Inspection and replacement or repair of spares. The damaged or broken spares are repaired and the same is inspected to the standards. Reassembling. The next course of action is assembling the parts in reverse manner of dismantled order. Trial run. After completion of assembly, electrical connections are to be given. Run the machine manually and lubricate accordingly. Finally, the machine should have a trial run for some time and be observed for any unusual sound. Inspection with standards. The machine is finally checked or inspected for geometric accuracy, safety hazards, etc., according to the manufacturer's standards. Maintaining records. All the activities related to faults, spares changed, etc., to be recorded in the inspection report or maintenance record or machine history cards suitably for future reference. Inspect the following items of center lathe as per the given checklist and tick it in appropriate column. Check and adjust the tension of the belt. Bearing sound. Check the movement of the carriage of the lathe. Working in all speeds. Run the machine on different spindle speeds and check the speed. Working in all feeds. Engage the power feed and check the longitudinal and transverse feed movements. Check the function of driving clutch by operating the clutch lever. Tailstock's parallel movement. Check braking system. The movement of the cross slide and the compound slide. Check the oil level or coolant level and the functioning of the lubricating or coolant pump. Electrical controls. Check the safety guards and ensure that they are in position.
In this video, we have learned the basic function of the maintenance department is the upkeep of the machines and equipment in good operating condition. Machines must be handled and maintained carefully in order to give good and long service. Conduct periodic inspection of machines and equipment as per the checklist. Thank you for watching. Hello everyone, welcome to this video of Monitor Machine as per Routine Checklist. The machine tools are of high precision and are sensitive and expensive. They must be handled and maintained carefully in order to give good and long service. In this video, we will inspect various lathe machine tool parts, understand lubrication, and operate and check the movements of the machine parts before machining.
A lathe is a machine tool that rotates a workpiece about an axis of rotation to perform various operations such as cutting, sanding, knurling, drilling, deformation, facing, and turning with tools that are applied to the workpiece to create an object with symmetry about that axis. A lathe should have provision to hold the cutting tool and feed it against the direction of rotation, to have parts fixed and sliding to get a relative movement of the cutting tool with respect to the rotation of the work, to have accessories and attachments for performing different operations. Let us now understand the various parts of lathe. Lathe bed. The lathe bed generally consists of a single casting. In larger machines, the bed may be in 2 or more sections accurately assembled. Web bracings are employed to increase the rigidity. For absorbing shock and vibration, the beds are made heavy. The bedways are of 3 types: flat bedway, V bedway, combination bedway. Headstock. The headstock contains the motor, spindle, gears and controls for the rest of the lathe. Spindle and spindle nose. The spindle is the primary rotating element of the lathe. The spindle nose is the attachment point for a variety of work holding. There are a variety of spindle standards and sizes. Chuck. Chucks are a convenient way to hold workpieces on the lathe. A 3-jaw scroll chuck is installed on the spindle nose. Power switch. On some lathes, the power to turn the spindle on is located on the headstock. On other lathes, it may be a lever on the apron of the carriage. Spindle speed control. On many lathes, the spindle speed is controlled by selecting a combination of gear ratios. On others, the spindle may be controlled mechanically by devices such as continuously variable speed units or electrically by variable frequency drives. Power feed gear levers. The gear ratio for the lead screw and feed rod may be set by changing the combinations of the power feed gear levers. This is done in a variety of ways on different lathes. Power feed direction selector. The direction of rotation of the feed rod or the lead screw can be reversed by changing the position of the power feed direction selector. Function of headstock. To provide a means to assemble the work, transmit the drive from the main motor to the work. To accommodate shafts, gears and levers for a wide range of varying work speeds. To ensure arrangement for lubricating the gears, shafts and bearings. Carriage. Carriage is the feature of a lathe that provides the method of holding and moving the cutting tool. It can be locked at any desired position on the lathe bed. It consists of two major parts, namely apron and saddle. Apron. The apron is the structure is located on the front face of the carriage. The apron is responsible for receiving power from the lead screw or the feed rod and transferring it to power either the carriage itself or the cross slide. The main parts of an apron are traversing hand wheel, feed lever, feed selector, lead screw engagement lever. Saddle. It is a H-shaped casting having V-guide grooves at the bottom face corresponding to the lathe bed ways for mounting on the lathe bed and for sliding. It supports the cross slide, which in turn supports the compound rest and the tool holder. Parts of a saddle. Cross slide. The cross slide is mounted on the top of the saddle and it provides cross movement for the tool. This is fitted at right angles to the bed and is moved by means of a screwed spindle fitted with a handle. A graduated collar mounted on the screw rod along with the hand wheel helps to set the fine movements of the cross slide. Compound rest. The compound rest is fitted on the top and to the front of the cross slide. The compound rest can be swiveled horizontally through 360 degrees. Top slide. The top slide is fitted on the top of the compound rest. It supports the tool post which holds the cutting tool. The top slide provides a limited horizontal movement for the cutting tool. By swiveling the compound rest, the top slide can be set at an angle to the cross slide. Usually the compound rest is set in such a way that the top slide is at right angles to the cross slide. Cutting speed. Cutting speed is the speed at which the cutting edge passes over the material and it is expressed in meters per minute. Feed. The feed of the tool is the distance it moves along the work for each revolution of the work and it is expressed in millimeters per revolution. The factors governing the feed are tool geometry, surface finish required on work, rigidity of the tool, coolants, cutting fluids, are essential in most metal cutting operations as they play an important role in reducing the wear of cutting tools. The following are the main purposes of cutting fluids or lubricants. To cool the cutting tool and the workpiece as heat is generated during cutting operation because of friction between the tool and the workpiece. To cool the cutting edge of the tool and to prevent any wear on the tool. To prevent the formation of chip welding. To give a good cutting efficiency to the tool. To give a good surface finish on the job. To act as a lubricant for the tool and the machine. Now let us monitor the lathe machine as per routine checklist. Clean the machine, check the safety guards and ensure that they are in position. Check the tension of belt. Check the free movement of carriage tailstock of the lathe. Run the machine on different spindle speeds and check engage the power feed and check the longitudinal and transverse feed movements. Check the function of clutches by operating the clutch lever. Check the movement of cross slide and the compound slide. Check the oil level and functioning of the lubrication. Check the coolant and the functioning of the coolant pump. Check the exposed gears are fitted properly. Switch on and check the running condition of machine before machining.
In this video, we learnt about the different parts of lathe, understanding the purpose of cutting fluids, monitor and check the movements of the machine parts before machining. Thank you for watching. Hello everyone. Welcome to this video of Read Pressure Gauge, Temperature Gauge, Oil Level. Welcome. In this video, we will learn about the pressure and temperature gauge and to check oil levels of a hydraulic reservoir.
What is pressure gauge? The devices that are used for measuring pressure are called pressure gauges. Gauge pressure is the pressure relative to atmospheric pressure. For the pressures above atmospheric pressure, gauge pressure is positive. For the pressures below atmospheric pressure, gauge pressure is negative. The pressure gauge is also known as pressure meters or vacuum gauges. Most gauges calculate the pressure relative to atmospheric pressure as the 0 point. Hence, this form of reading is known as gauge pressure. Pressure gauges are analog as well as digital. The commonly used pressure gauge is Bourdon tube pressure gauge. The pressure-responsive element of a Bourdon gauge consists essentially of metal tube called Bourdon tube or spring, oval in cross-section and bent to form a circular segment of approximately 200 to 300 degrees. This tube has two ends, one that is free to movement and the other end is fixed. The pressure to be measured is connected from the fixed end and the free or moving end is connected to a pointer. In the case if the pressure is positive, the movement of the tube will be outward. In the case if the pressure is negative or a vacuum pressure, the tube moves inward and the pointer converts this inward or outward movement to read the pressure. The motion of the free end, commonly called tip travel, is a function of tube length wall thickness, cross-sectional geometry and modulus of the tube material. Temperature gauges measure the thermal state of a homogeneous substance. The measuring system must be brought as closely together as possible with the body to be measured. Types of temperature gauges. Bimetal temperature gauges. Temperature measurement is made by a bimetal system placed inside the thermometric sensor. The temperature variation causes the bimetal spiral or helix to rotate on its axis. Value of this rotation is then indicated on a graduated temperature scale. Bimetal thermometers are available for temperature ranges from 70 degrees centigrade up to 500 degrees centigrade. Inert gas temperature gauges. These gauges are made with a bulb sensor, a capillary and a case containing a tubular spring filled with a pressurized inert gas. Any temperature change causes a change in the inner gas pressure. This pressure variation is then measured by a Bourdon tube system and indicated on a dial with a scale with temperature units. Inert gas temperature gauges are available for temperature ranges from -200 degrees centigrade to 700 degrees centigrade. They are designed for heavy applications and can sustain severe shocks, vibrations, and resist to high ambient temperatures and humidity. Inspection is necessary for any machine or equipment where remarkable risk to health and safety may arise from wrong installation, reinstallation, or any other circumstances. The purpose of inspection is to find whether machine can be operated, adjusted, and maintained safely. The need for inspection and inspection intervals to be determined through risk assessment. The summary of inspection should be recorded and same should be kept at least until the next inspection of that machine. Machine or equipment that required inspection should not be used unless the machine has been inspected. Let us now see the function of inspection. Periodic inspection of machines and equipment as per checklist. Annexure 1. Keeping basic records of each machine and equipment. Preparation of list which need for repairs or spare for replacements. Analysis of inspection report and systematic review of reports of machines or equipment. Assigning of frequency of inspection. Hydraulic system. Any working or control system that uses liquid as the transmitting fluid is known as hydraulic system. The basic hydraulic system consists of the following elements: a reservoir to store the hydraulic fluid, a pump to provide fluid pressure to the system, a control valve to direct the flow of fluid, an actuating unit such as a cylinder, a suitable hydraulic fluid, piping or tubing to circulate the fluid through the system. To check the oil level of hydraulic reservoir, put off the hydraulic system, drain the oil from the reservoir, remove the inspection cover after unscrewing mounting. Locate and unscrew the suction strainer. Clean strainer with kerosene and blow it with compressed air. Clean inside of the reservoir thoroughly. Screw the suction strainer after inspecting it for damages. Replace inspection cover and gasket. Tighten mounting screws. Refill the oil in the reservoir after filtering the oil using mesh. Check for oil leakage through inspection cover. Confirm no leakage of oil. Check for oil level. Lubrication survey is a key part of a good preventive maintenance program. Preventing equipment downtime is directly reflected in increased productivity. The best guarantee for good maintenance is to follow the manufacturer's directives for the use of lubricants and greases. That is, identify the oiling and greasing points, select the right lubricants and lubricating devices, apply the lubricants. The manufacturer's manual contains all the necessary details for lubrication of parts in machine tools. Lubricants are to be applied daily, weekly, monthly, or at regular intervals at different points or parts as stipulated in the manufacturer's manual. These places are indicated in the maintenance manuals with symbols. How does a lubrication survey work? by points of lubrication, recommended LE products, application methods, drain or lube intervals, special remarks. The material is compiled and a report is returned with the recommended lubricants for all your equipment included. Estimation is the method of calculating the various quantities and the expenditure to be incurred on a particular job or process. In case the funds available are less than the estimated cost, the work is done in part or by reducing it, or specifications are altered. The following essential details are required for preparing an estimate: drawings like plan, elevation and sections of important parts, detailed specifications about workmanship and properties of materials, etc. A cost estimate contains approximate cost of a product, process or operation. The cost estimate has a single total value and it is inclusive of identifiable component values.
In this video, we learnt about a pressure gauge and the working principle of Bourdon tube pressure gauge, types of temperature gauge and their range, working and requirement of lubrication survey to check the oil level of the hydraulic reservoir. Thank you for watching. Hello everyone, welcome to this video of
Assemble simple fitting using dowel pins and tapped screw assembly using torque wrench.
In this video, we will see few common methods used to assemble simple fitting components together. Additionally, we will see which factors can cause assembly failures. In machine shop assembly, various methods are used for securing components together. A few of the common methods are doweling. This is used for accurate positioning of two or more parts. This allows the parts to be separated and relocated in position. Different types of dowels are used depending on the type of assembly. The components doweled are always fixed with retaining screws in the assembly. Pinning. This is also a method of locating and securing components together. Pins are of different types. Parallel pins. These are fitted like dowels in reamed holes and held in position by a retaining ring. Taper pins can be dismantled easily and assembled without any change in location. The holes for fitting taper pins are finished using taper pin reamers. Spring pins. This eliminates the need for drilling and reaming of the assembly together. Peening. When parts are to be assembled, this is one method of assembly. This is similar to riveting. Brazing. This is a process of joining metals by using layer of non-ferrous metal between the surface to be joined. The alloy used for brazing is known as spelter, combination of copper and zinc. Using of adhesives. The adhesives commonly used are epoxy adhesives. This adhesive gives a strong bond between materials to be assembled. Possible causes of assembly failures. Poor assembling. Errors in assembly can result from various causes such as ambiguous, insufficient or inappropriate assembly procedures, misalignment, poor workmanship and inadvertent errors performed by workers during assembly. Example: Failure of nut and stud assembly by fatigue can occur if any sort of loosening of nut subjected to external load happens under such conditions. Therefore, it is essential to have proper information regarding the sequence of tightening the nuts and torque to be used for tightening purposes. Poor service conditions. Failure of engineering components can occur due to abnormal service conditions such as exposure to high rate of loading, unfavorable environment, and high or low temperature conditions. These conditions can cause oxidative, corrosive, and erosive damage to the component, which it may not be designed to withstand. Investigation of the design, manufacturing process, and material compatibility is essential to establish the contribution of abnormal service conditions to the failure. Therefore, the failure of an engineering component is a complex phenomenon that requires a thorough investigation. Weight of raw material. Calculate theoretically weight of material. Calculate volume of material and multiply with density of material. It gives you the exact weight of raw material required. While calculating weight, do not consider final dimension, always consider plus size for machining and other operation. Cost of operation. Decide each operation to be performed on flanges like drilling, machining, and boring. While selecting the process, do take care of sequence of operation as it matters a lot on costing. You need to allot time required for a particular operation, considering all factors of machine. On their basis of price of machine, depreciation, and cost of electricity consumed, you need to finalize cost of machine running per hour. Now multiply time required for a particular operation and machine running cost per hour. Procedure to assemble fitting using dowel pins and cap screw assembly using torque wrench. Check the raw materials size. File part 1, 2 and 3 to overall size, maintaining parallelism and perpendicularity. Check the flatness and squareness with tri-square and dimensions with vernier caliper. Apply marking media on part 1 and 3 and mark the dimensional lines as per drawing. Punch witness mark and drill hole marks. Chain drill, cut and remove the excess metal on part 1 and file to size. Similarly, chain drill, cut and remove the excess metal in part 3 and file to size and shape. Fit part 2 in part 1 and 3, maintaining tolerance plus or minus 0.04 mm. Assemble part 1, 2 and 3 all together and clamp it using parallel clamps, maintaining squareness. Hold the assembly setting in drilling machine table along with suitable fixtures.
Drill, countersink and ream the hole as per drawing and fix diameter 5 mm dowel pin without disturbing the assembly setting.
Similarly, drill, countersink and ream the other dowel pin hole without disturbing the assembly setting and fix other 5 mm diameter dowel pin. Drill holes for tapping in part 1 and 3 without disturbing the assembly setting.
Separate the assembly setting, drill diameter 6.6 mm through hole and diameter 11 mm counter bore to the depth of 8 mm in part 3 to enter the cap head screws.
Hold part 1 in benchwise and cut M6 internal thread in 2 holes to fix cap head screws. Clean the threads without burrs. Finish file in part 1, 2, 3 and deburr in all corners of the job. Reassemble part 1 and 3 along with dowel pins and cap screws.
Fix the cap screws.
Fit part 2 in part 1 and 3 opening slot. Apply a little oil and preserve it for evaluation. Procedure to fix dowel pins. Keep position 1 and position 2. Tighten the socket head screw such that there is a gap of 1 pitch of the socket head screw. Drive the dowel using a hammer such that about 5 mm of the chamfer side of the dowel enters into the reamed hole. Check for the perpendicularity. Drive the dowel into the reamed hole such that chamfered end of the dowel enters fully into the position 1 as shown.
Drive the dowel keeping pin punch diameter 5.8 over the radius of the end of the dowel such that the chamfered end of the dowel enters into position 2.
Drive the dowel in about 10 mm into position 2. Tighten the socket head screw such that there is no gap. In this video, we learnt about various techniques to secure components together, possible causes of assembly failures and how to rectify them, procedure to assemble simple fitting using dowel pins and cap screw assembly